Example 10 says to find the exact values of the cosine of negative 675 degrees and the cotangent of negative 14 pi over 3. So this is going to involve all of the things we've learned plus what we know about the unit circle. So the cosine of negative 675 degrees. So I know I can figure this out if I can put this angle on the unit circle, because I know my unit circle. So I'm going to start with negative 675 degrees, and I'm going to add 360 to it, because I need to get up to add that to make it, to get to what I need. Well, this should make negative 315 degrees. And if I add 360 again, I'm going to end up with 45 degrees. Okay, so the cosine of 45 is really what I'm looking for. So the cosine of negative 675 is the same thing as the cosine of 45, which is the square root of 2 over 2. Right, so that's the first one. That's very good, very nice. You could have also, at this point, you could have said, oh, hey, the cosine of a negative angle is the same thing as the cosine of a positive angle. And so the cosine of 315 degrees is square root of 2 over 2, so that means the cosine of negative 315 would have to be the same thing. So you could have done that as well. So more than one way to do this type of problem. The cotangent of negative 14 pi over 3. I'm going to do the same kind of method. I'm going to find an angle on the unit circle, and I'm going to figure this out for myself. So the cotangent of negative 14 pi over 3, that is not on the unit circle, so I'm going to add 2 pi to it, which is going to be the same thing as 6 pi over 3. So that would make negative 8 pi over 3. Not going to work. Add 6 pi over 3 again. That gives me negative 2 pi over 3. I'm going to add again. Again, you could stop there too and figure stuff out, but I'm not. And then you'd see this would be 4 pi over 3. So that's something that I know. So I know here that the cotangent of negative 14 pi over 3 is the same thing as the cotangent of 4 pi over 3. Now, at this point, we haven't really talked a whole lot about the exact values of sine, or we haven't talked really the values of tangent, like we have sine and cosine. Well, tangent, and when we think about our circle, and we think about our equations, when we look at tangent, tangent is the same thing as sine over cosine. Cotangent is the same thing as cosine over sine. That's the same thing. So when if we say one, we can use the values of those to figure it out, right? Remember, because tangent is the y over the x. So cotangent would be x over the y. Well, our x's and y's are cosine and sine. So what we need to do is just use our values on the unit circle to figure this all out. Well, the cosine of 4 pi over 3. What's the cosine of 4 pi over 3? This should be negative 1/2. Now, the sine of 4 pi over 3 is negative square root of 3 over 2. Yay, fractions, right? So from here, you're not done. You have to simplify and probably, actually certainly, you're going to have to rationalize your denominator. Well, quick thing on fractions. In order to divide fractions, you can think of them as multiplication, right? Multiplication is just another form of division, or division is another form of multiplication. We can look at this thing as negative 1/2 is being multiplied by the reciprocal of the denominator, which is negative 2 over the square root of 3. This is completely fine to do. Now, our negative values they will cancel. So we end up with a positive number. 1 times 2 makes 2. 2 times the square root of 3 makes 2 times the square root of 3. Now, you're not finished. Okay, so we can cancel these. And then lastly, what we need to do is we need to rationalize. Well, to rationalize a function, we have to multiply by a number that gets rid of the square root in the denominator. This is a single term, so we can multiply by the square root of 3 over the square root of 3. That'll free it up. And that becomes a new number, which is the square root of 3 over 3. So lots of additional work for that problem because we're not talking about sine and cosine. These you don't need to memorize these values of tangent. They could be useful down the line, but it's not necessary. You can always use sine and cosine to figure them out.